During the past decade, we witnessed unprecedented growth in the collection of data on human activities. This provides an opportunity and a challenge to integrate heterogeneous sources of data and collectively mine it. Many of these datasets can be best modeled as graphs. Hence, the problem can be stated as merging graphs coming from multiple sources. This is a well-studied and a challenging problem, as the underlying subgraph isomorphism problem, known to be NP-complete. Our primary goal is to develop a scalable algorithm to align two large graphs. The graphs are assumed to be similar but not isomorphic. We propose GASANA, Global, Structure-Assisted, Network, Aligner. The intuition behind GASANA is that, in the graphs coming from different but similar sources, we can group elements of these graphs, by comparing them with some pre-identified reference points. For example, this is Bob. And this is Alice. Alice and Bob are very close friends, and they are following each other in almost all social networks. However, their preferences differ. For example, while Alice is a huge fan of famous director Mr. Brown, Bob prefers Ms. Black. As a consequence, Bob follows Ms. Black, and Alice follows Mr. Brown. And, there are so many people, like Bob and Alice. Some likes Ms. Black's movies, while others prefer Mr. Brown's. Ms. Black and Mr. Brown can be used to distinguish others. We can find more Ms. Blacks and Mr. Browns. We call them reference points. We can group other people, by comparing their closeness to these reference points. For example, if Alice follows Mr. Brown in the network A, with high probability she is also going to follow him in the network B, if we assume that network A and B are similar. This is Bob in network A, and this can be Bob in network B. As you can see, both of them have very similar distances to our reference points. Therefore, we should consider them as a possible match and look structural and attribute similarities of them, and their neighbors, before making our final decision. In another example, John, and can be John, have very dissimilar distances, to our reference points. Therefore, they are unlikely to represent the same person, hence, we can safely skip the detailed comparison. For a given set of references, GASANA groups elements of the graphs, based on their distances to the reference points. Then it only compares matching groups of two graphs. This reduces the problem space significantly. In the last step, now, we can compare possible matches by considering all of the information that we have. You can find more information about GASANA, and the source code, in the following URL.